Hello everyone, welcome to the Consumers University. Myself, Mr. Ankit Khandelwal, Assistant Professor from the Department of Faculty of Computer Engineering. We are having a discussion on the course Computer Organization and Architecture, and the topic of discussion is Direct Memory Access. The content of the lecture are as follows. First of all, we will see the purpose of DMA, why the DMA is used in the computer system. Basically, the DMA, the use of DMA is to transfer the data between the peripheral unit and the memory, or vice versa directly, without involving the central processing unit. Then we will have the block diagram of the DMA transfer, uh, in which we are using a device which is called DMAC, or Direct Memory Access Controller. We will see the sequence of DMA transfer, that how this transfer take place directly without involving the CPU in between the T units, that is peripheral unit, and the memory. Then we will have a minimum requirements for initializing the DMA controller before the transfer has to be take place between the two units, peripheral and the memory there. And in the last, we will have a discussion on the transfer modes of the DMA there. Basically, there are four transfer modes. We will see each and every transfer mode in this particular section. Now, after this lecture, the students will be able to understand the DMA basics. They will learn about DMA and why it is used in the computer system there. Then they will have a good knowledge about the DMA controller and its operation. That is how this DMA controller interacts with memory, peripheral, and the CPU. We will have a discussion on the DMA transfer. So after studying DMA transfer modes, basically burst mode and the cycle mode, how the transfer take place in both these two type of modes. Say. Now, this DMA transfer uh, is a hardware controlled input output transfer technique there. Okay, hardware controlled input output transfer technique. So it is mainly used for high speed transfer. That means what we want a high speed data transfer basically in between input, output, and memory, or vice versa. Okay, where the speed of the peripheral is generally faster than the CPU. Now, in program controlled input output, or status or interrupt driven input output, in both these type of transfer techniques, what is there? There is some software. As we know that software is a program, and in program there are instructions. So these instructions are to be fetched, they are to be decoded, and then execution will take place to transfer the data there. So this will take some time in comparison to the hardware controlled input output transfer technique, where there is no software, there is just a hardware involving in between the transfer of the data from one device to another device there. So DMA transfer is what? Software. It is software independent. Okay, it is software independent, and hence much faster in comparison to the other input output transfer techniques there. So here a device known as DMA controller, direct memory access controller, in short it is called DMAC, is responsible for the data transfer there, right? Now you will see this particular block diagram. In this block diagram, we have the three major components, that is CPU. We have a CPU there, we have a peripheral unit, and we have a memory there. Now, what is there? Uh, we want that either there is a transfer from peripheral unit to the memory there, or from memory to the peripheral unit. Okay, we want this transfer or this communication of the data between these two devices to be directly. Okay, directly. That means there must be no involvement of the CPU. That means if, let us suppose, this peripheral unit wants to send the data to the memory, then if there is no DMA, okay, if there is no DMA, how this particular communication will take place? First of all, the data will go to the CPU. Okay, in the first step, from the peripheral unit, the data will go to the CPU. This is the first step. Okay, data will go to CPU there. Then this from the CPU, using this data bus, the data will go to the scenario if there is no DMA controller. Similarly, if let us see that if there is a transfer from memory to the peripheral unit, then how it will be done? It will first of all the memory will send its data to the CPU. Okay, it will send it to the CPU there, right? Then from the CPU, this data will go to the peripheral unit there. So in both the cases, what is there? If there is no DMA controller, there is a intermediate device, that is CPU, which is going to happen this task there. And we know that in comparison to the peripheral unit, CPU is much lower because it is involvement into many other tasks also. So this transfer will take place sometime. So what we want that this whole data transfer between the peripheral unit and the memory should be taken in place between through the some device where there is no involvement all the um, of the CPU there. But for that, what we have to do, whenever this peripheral unit wants to send the data to the memory there, first of all, this peripheral unit has to tell the DMA controller. Okay, then this DMA controller will send the message to the CPU that this particular device wants the address bus, data bus, and the control bus of the CPU for the transfer to be taken place between peripheral unit and the memory there. Okay, so what is there? There will be a first handshake between peripheral unit and the DMA. That means there will be a request from this particular device to the DMA controller. In the first step, there will be a request. Okay. Then DMA controller will send the request to the CPU for the transfer. Okay. If CPU is involving in some work, this CPU will do its that work, and after that, it will grant the bus permission to the DMA controller. After getting this grant, whole communication, that is, whole this data is going to be transferred in between these two devices directly without having CPU there. Okay, this is how the DMA controller works in between the CPU peripheral unit and the memory there. Now, let us have this particular block diagram. This is how this whole thing is going to be take place. So we have a address bus, we have a data bus, and we have a control bus over here, right? Uh, these address bus, data bus, and control bus are directly connected to the microprocessor. Okay. Now this is DMA. Okay. This is the DMA block. What is the role of the DMA controller? DMA controller is going to send the request by this HRQ, okay, by this HRQ to the microprocessor for the transfer to be taken place between the memory and the peripheral devices. For that, what we want? We want that all these data bus, address bus, and the control bus should be connected to the DMA controller. That means initially they are connected to these point A. Address bus is connected to the this switch A. Data bus is also connected to the switch A. Control bus is also connected to the switch A. But after getting the bus grant from the DMA controller by the microprocessor, all this data lines, all these data lines will be connected to the B point there. Okay. So all these will be connected to the B point, and when it is connected to the B point, DMA controller is becoming the master to control all this address bus, data bus, and the control bus there. So let us have a look on this particular block diagram, how this thing take place. Now let us suppose we are taking the scenario there is a transfer transfer between peripheral and memory. Okay, memory. So first of all, what will be there? The peripheral device, that is this disk controller, okay, will send the request to the DMA controller. Okay, so in the initial step, DREQ, which is called data request. Okay, data request will be sent to the DMA controller there. So DMA controller will come to know that this particular peripheral device wants to transfer the data to the memory there. Now, after getting the request from the peripheral device to the DMA controller through this DREQ, okay, the DMA controller will now send the request signal to the microprocessor. So here you will see that there is a one pin which is called hold request. Okay, hold request, HRQ. HRQ is hold. This request will be sent from the DMA, will be sent from the DMA to the microprocessor. Okay, so microprocessor will be involving in some task. It will get this request. That means there will be an interrupt. So first of all, microprocessor will do its task, and then we'll see there is a request from the DMA controller. Then what will happen? Microprocessor will generate a signal which is called hold acknowledgement. Okay, this hold acknowledgement signal will be given to the DMA controller that you can access the address bus, data bus, and the control bus for this transfer. So as soon as this DMA controller will get the hold acknowledgement, these all buses will be connected to the point A there. Okay, this connection will be connected to the point A there. Now all this address bus, data bus, and control bus are connected to the DMA controller. So DMA controller, after getting the access of these all bus, will send the acknowledgement to the peripheral device that you can now transfer the data between the two devices, that is memory and peripheral, directly by giving this data bus, because you see that the data bus is connected to the peripheral and also the control bus is connected to the peripheral there. So there will be a two thing, either this peripheral will send the data to the memory. Okay, so whenever this task is going on, that means this is some write operation is involving. Okay, this is the first point. And or from memory, the data will be transferred to the peripheral, to the peripheral. This is a read of the read operation. So this is how this whole thing will be taken place there. So let us see once again what is happening over here. First of all, if there is a transfer between these two unit, memory or the peripheral unit there, the request from the peripheral device will be sent to the DMA controller. Okay, the first step is that this request will be sent to the DMA controller there. After that, let me erase this particular thing and show you. So here what is being done, this first whole data request will be sent from the peripheral to the DMA controller there, then DMA controller, this is the first step. Okay, the second step, DMA controller will send the whole request to the microprocessor. Microprocessor will get an interrupt signal. After doing its task, the microprocessor will generate the hold acknowledgement from the microprocessor to the DMA controller. As soon as this DMA controller will get the hold acknowledgement, this bad control of the buses, that is address bus, will be connected to the point B. This data bus will be connected to the point B, and the control bus will also be connected to the point B there. Okay. Now this DMA controller got an access of all these buses there. Now what will happen? DMA controller will send. This is the fourth step where DMA controller will send the acknowledgement signal to the peripheral device that you can now do the transfer between the memory or from memory to the peripheral directly by using the data bus and the control bus. Now, if the transfer is being taken place between the peripheral to the memory, then it is called write operation. So it will become input output write operation there. Now, if the data is transferred from memory to the peripheral, then this is called read op will be called IO read operation. So that's why it is being overwritten here IOR and IOW. So whenever there is a input output read and write operation, there will be a memory read and write operation there. Now this was about the DMAC controller. Now we will have a sequence of DMA transfer there. So first of all, microprocessor will initialize the DMAC by giving the starting address and the number of bytes to be transferred. Okay, so let us suppose we want to transfer 1 KB of file. Okay, that means 1024 bytes. So what the microprocessor will do? Microprocessor will initialize the counter value to 1024, which is in controller is having a register which is going to hold this value. Okay, now what will happen? An input output device, okay, requests the DMAC controller. As I told you, this was the first step. There will be a request from the input output device to the DMAC to perform DMA transfer through the DREQ line. Okay, so through the data request line, this request will be sent to the DMAC controller. Now, after that, what will there? The DMAC in turn sends a request to the microprocessor as shown over here. See, as shown over here, this first step, peripheral device sends the request to the DMA controller through DREQ. After that, DMA controller sends the request to the microprocessor through HRQ there. So this was the second point. The DMAC in turn sends a request signal to the microprocessor through the hold line there. Okay, through this hold line. So this is the hold line. This one. This one is the hold line through which the DMAC controller is sending the request to the microprocessor there. Now, after that, microprocessor finishes the current machine cycle. So it is involving in some work. So that work will be finished by the microprocessor there. And then there will be a release of the system bus, okay, from it there. It also acknowledges receiving the hold signal through the HLDA line there. So after getting the hold request, microprocessor will generate the hold acknowledgement to inform the DMAC controller that you have now access on the address bus, data bus, and the control bus there. So DMAC acquires control of the system bus there. The DMAC sends after getting the control of the system bus, DMAC will send the data acknowledgement signal to the peripheral and DMA transfer begins there. Okay, so after every byte is transferred, the address register is incremented because program is written in a program is there. This program is going to be sequentially. So we are on this address, then we will go on this address, then we will go on this address. Okay, and the counter register will be decremented. So initially we have 1024. So when the first byte will be transferred, this counter will become 1023. That means 1023 bytes are left there. When this byte will be transferred, then the counter value will become 1022. In this way, the data transfer will take place. So this will continue till the count reaches 0. That means terminal count. When we will reach to the terminal count, now the DMA transfer is completed, and again whole data bus, address bus, and the control bus will be given access to the microprocessor layer. So at the end of the transfer, the system bus is released by the DMAC, and it will make that to 0 there. Okay, the signal will be made to 0. So the microprocessor takes control of the system bus and continues its operation there. So this was about the sequence of the DMA transfer. Now, what are the minimum requirements for the DMA controller? So the DMA controller does DMA transfer through its channel there. Okay, so the minimum requirement. So the minimum requirements are what? These are the minimum requirements, that address register to hold the initial address. So to store the starting address for the transfer there. Then counter register, that will how many number of bytes you want to transfer. This is going to be held by this counter register there. Our data request signal from the input and output devices. This must be first of all sent by the input and output device, and input and output device. So after getting the access of all the buses by the DMAC controller, there will be a acknowledgement signal from DMA controller to the input and output device, which is called data acknowledgement signal. Then only this transfer will take place. So this is the minimum requirement of the DMAC controller there. Now we are going to have a discussion on the transfer mode of uh, DMA there. So this 8237 has four modes there. What is this 8237? 8237 is the number of the DMAC. Okay, you can say that it is the number of the DMAC 8237. Okay, device number. So Intel has released this particular device, which is with the number 8237 there. Okay. So this DMA has four modes of data transfer. The first is called single byte transfer mode or cycle stealing there. So as the name is suggesting there, we are going to transfer a single byte in this transfer mode. And cycle stealing means that we are going to steal every time the data bus from the microprocessor for this transfer there. So once the DMAC becomes the bus master, okay, it will transfer only one byte in this particular mode there, and then return the bus back to the microprocessor. Okay, this will be sent to the microprocessor there, right? So this will be sent to the back to the microprocessor there. So as soon as the microprocessor perform one bus cycle, okay, it will perform one bus cycle. DMAC will once again take the bus back from the microprocessor there. Hence, both DMAC and microprocessor are constantly stealing bus cycles from each other. That's why it is called cycle stealing transfer mode there. So it is the most popular method of DMA because it keeps the microprocessor active in the background. Okay, that microprocessor can also do the work during this particular transfer. So after a byte is transferred, the CAR and the CWCR, which is called address register, and the count register are adjusted accordingly. The CAR is the address register for the DMAC controller, and CWCR is the word count register for the DMAC. Okay, so the CWCR will be holding the number of bytes which are to be transferred or which are to be transferred there, and CR is going to hold the address from which particular address the data has to be transferred there. The system bus is written to the microprocessor for further bytes to be transferred. The data request line must go to the active again, and then the entire operation is repeat. So in this way, the cycle stream mode works there. Now there is a called block transfer also. So in block transfer, what is there? So in this mode, the DMAC is programmed to transfer all the bytes in a one complete DMA operation. So now see here, DMA wants to send all the bytes in a one complete DMA operation. But after a byte is transferred, the CAR and CWR are adjusted accordingly. So in all the cases, this particular values, whenever there will be a transfer, these are going to be adjusted accordingly. Now the system bus is written to the microprocessor there. Okay, only after all the bytes are transferred, that is, terminal count is reached, or end of program signal is issued by the issued by the that is microprocessor there. That whole transfer has been taken place. The counter register value has reached to the terminal count, that is 0. Now all the buses will be transferred to the microprocessor. So it is the fastest form of DMA, but keep microprocessor inactive for a long time. So here the microprocessor will be inactive until the whole data transfer is being taken place there. That's why it is called block transfer mode there. Okay, that's why it is a block transfer mode. Now, the DREQ signal needs to be active only in the beginning for requesting the DMA service initially. Okay, therefore DREQ, that is data request, can become low during the transfer. So what was there from the peripheral? From the peripheral, there is a request which is called DREQ, okay, which is given to the DMAC controller. So when this particular peripheral device wants to transfer the data, initially this will become 1. So after getting this request from the DMAC controller, and DMAC will get the access of all the buses, this particular value will become 0 in this particular thing there. Okay, this will be 0 until when all the transfer has been taken place there. Fine. Now let us look on the particular thing. Mm, Next mode of transfer is, we have next mode of transfer, that is demand transfer mode there. Now it is very similar to the block transfer, except the data request must active throughout the DMA operation. So in the that is block transfer mode, initially data request is 1. When the transfer is going to be take place, the value of DREQ will become 0 there. But in the demand transfer mode, what we are saying, that this data request must be active throughout the DMA operation. That means at every time you have to cap the data request to 1. Okay, so this is similar to the block transfer, but there is only one change, that this will be equals to 1. Now, if during the operation data request goes low, okay, if it will become 0, the DMA operation will be stopped and the buses are written to the microprocessor. This is the difference between the block mode and the demand transfer mode there. In the meantime, the microprocessor can continue with its own operation. Once DREQ again becomes high, the DMA operation continues from where it has stopped there. Okay. Now, transfer mode, last transfer mode is cascade transfer mode there. So in this mode, what is there? More than one DMAC are cascaded together. Okay, so whenever we are going to have a more than one DMAC controller inside the computer system, that means more number of peripheral devices can be connected through this DMAC controller to access the transfer between the peripheral unit and the memory there. So it is used to increase the number of devices interface to the microprocessor. So here we have a one master DMAC. So there will be a one master DMAC, and other all the DMACs will be slave. Okay, are connected. So the slaves are connected to this master DMAC there. The slaves have uh, HRQ to the master on the DREQ of the master there. So there will be a data request signal from the slaves to the master there. And the master gives hold request to the microprocessor to on the hold of the microprocessor. Let us see this block diagram. No, sorry. This is the whole thing there. Okay. So how it is happening? This is DMAC, which is master DMAC. Through this master DMAC, what we are connected? We are connecting another. This is DMAC 1. This is DMAC 1. This is DMAC 2. Okay. These are connected to this master DMAC, and this master DMAC is connected to the microprocessor there. So whenever there is a thing, how this is going to be dealt with, it is that there will be a data request signal from this particular device to the DMAC controller. So there will be a hold request signal over here. Here it is generating DREQ signal. Okay. Similarly, this data request signal will be from this particular DMAC2 to the DMAC controller. After getting the request, this request will be transferred to the microprocessor there. So in this way, in this transfer mode, there is a thing there. That is, we are having one or more DMAC controller. That means we want a number of peripheral devices connected to the microprocessor. Now, this was the thing. So in the conclusion, what we have seen there, that we have seen the DMA, that is direct memory access. What is the purpose of using the direct memory access? That we want to transfer the data between the two devices, that is peripheral and memory, or from memory to the peripheral directly without involving the CPU. Because whenever there will be a transfer through the CPU, this will take some time in comparison to the direct transfer there. So that's why we use our DMAC controller, which is with the chip number 8237 in the computer system, which take all this whole scenario, how to transfer the data directly between these two devices.